Hi, my name is Tara, and I'm a Senior Technical Product Manager with the Cloud and Enterprise Data Division. Today, we're going to talk about building Xamarin-based applications using Azure Database Services, which is data-driven and at the same time intelligent. But before that, let's look into our data platform capabilities. With Azure, organizations have access to a whole range of services that allow them to use the right tool for the right job when developing applications. In the cloud, organizations can collect and manage data in the form in which it's born and stored in the form that best suits an application's needs. As you can see in this diagram, the bottom row is where you ingest and store the data, the different capabilities which we have today in Azure. The middle row is machine learning, stream analytics, HD Insight, and Data Factory, processing and making sense of the data. The top row is all about visualization. You're making decisions based on data. Tools like Power BI Embedded fits in really well in this layer. Alright, before jumping into any of the demos, we want to show you the schematics first. This architecture is built by us, but then it's been inspired by the work GeoSafe has done. We're using a Xamarin-based platform here, which is supported across different platforms: Android, iPads, iOS, and Universal Windows platform. As you can see, what we're doing here is we're storing all the 911 dispatch data into Azure SQL database. We're also enabling security features like dynamic data masking and row-level security for ensuring that there is a good amount of isolation between the customer's data and the jurisdiction these police officers are managing. The e-ticketing information is stored in DocumentDB, which is our NoSQL JSON store. For rapid cloud development and for getting great amount of information and insight from the architecture, we're using notification hubs for the notification. For small little data set, we're using Redis cache. There's also Azure Active Directory and Azure Search. We're using predictive analytics model using machine learning, and we're currently using a linear regression map, which is creating all those heat maps which you're going to see in the demo. Last but not the least, the visualization, which has actually been built here using Power BI Embedded. Let's have a quick look at the API design. As you can see here on the screen, we're using get incidents from the city ID. And that's exactly what's going to happen when you see all those incidents showing up on the dashboard of the police officer. A little bit more into the API design. When we call get incidents city ID, you specifically get incidents from that particular city ID and the jurisdiction. But when we call in get incidents all, it's going to bring in all the incidents across the cities into the dashboard. Let's have a look at a demo. Okay, so here's the source code for First Response Online, which you're seeing on your screen. But before we start looking at the application, launch it, and go through the complete mechanism in the backend, let me explain what First Response Online is. First Response Online, which is an inspired application from GeoSafe, is a communication and collaboration platform built to support first responders. It lets police officers, firefighters, and paramedics share critical data with each other in near real time. It supports iPhone, iPad, and PC and integrates with computer-aided dispatch and GPS tracking. Units in the field can update their status, complete traffic stops, and even query state and federal databases all without using the radio. First Response Online is powered by Azure. In order to build a business that handles major life-threatening incidents, they not only rely on Azure's proven scalability and availability, but also its breadth of features to get to market quickly. All right, the three things we're going to see in this demo. First experience is how easy it is to build Xamarin-based cross-platform applications using Azure SQL Database. Second thing we're going to evolve this application and show you how the breadth of Azure capabilities can be used to expand application capabilities sets using technologies like DocumentDB and Azure Search. Third, we're going to innovate and differentiate this application by turning data into actionable insights using technologies like Azure Machine Learning, Power BI, and its ability to connect and consume from multiple different Azure data services. All right, let's look at the demo now. So what I'm going to do is, this is the complete source code, and as you can see, we have the Droid, iOS, and Universal Windows platform available to you through the Xamarin platform. We are using the Universal Windows platform for this particular demo. Let me just go and hit F5. So First Response Online, when the screen comes up, there are a few things I want to talk about this demo. First thing, it's completely based on the city IDs. So you have different cities where you can just pick up and use this application against, right? There's some other settings right here which shows you the endpoint. Currently, the service endpoint is local because I'm compiling the app locally. But you can deploy your own service endpoint or web endpoint back into your Azure subscriptions. Okay, the scenario here is there is this police officer. His name is John Clarkson. So John Clarkson walks in, gets into his car, and he's now looking at the incidents dispatched to him by the dispatch center. Okay, so we enter. And this is the view which John Clarkson gets to see from his dashboard. Few things we could do right now. I could show you a map view. So we're in the city of Sammamish where he has the jurisdiction for that particular postcode or region code, right? Similarly, there are different police officers who would be managing their own jurisdiction. First thing John Clarkson checks for is the availability of fire services, ambulance, and other police services across the region or the specific zone where he has got his jurisdiction. Great, so he could actually see the data in real time, that the position of the other fire services and ambulances, where they are, so that in case of a necessity, he could actually reach out to them or they could see the data and come to the scene. So let's look into the incident. Now here is the one which has been assigned to John Clarkson by the dispatch center. So we're going to click on the speeding ticket or incident, I should say. And as you could see, it gives him a nice dashboard. This is all touchscreen. So he's going to navigate to that particular place where the incident has occurred. All these incidents are stored in Azure SQL database, and we'll show you the mechanism that how all this data sharing is actually happening in real time. But first, let's look at the scenario. So as soon as John Clarkson starts navigating towards the scene, there are some notifications being sent, and John Clarkson clicks on those notifications to get the complete details. And as you could see, there's just not speeding vehicle, but there is a person who's potentially injured as well. So the person who kind of broke the law was also injured at the same time. And you saw M8 actually is on the scene and has reached the scene in no time, saving somebody's life. All right. On the left-hand side, as you could see, some of the details here from the 911 call center, the phone number and the last name of the reporting party has all been masked. This complete feature is enabled by dynamic data masking, which is native to SQL Server Engine and is available across SQL Server on Linux or SQL DB in the cloud. Great. What we're going to do here is we're going to identify this person and if need be, issue a ticket. Once we click on it, we ask this particular person, sir, may I get to know your name? Because this person is kind of not very conscious. And as he's got some injuries, we couldn't really ask for the rest of the things like licenses or whether even he's carrying or not is something which we don't know. The person says his name is Joe. We want to show you a feature which is built into Azure Search. The officer hears, he said Joe, and he types in Joe to see whether this particular person has ever been issued a ticket in the past in this region. And he searches for Joe. All this data is now coming from Azure Search, where the Azure Search Catalog is built on the tickets being issued in the past to offenders. Now, if you could see here, there are quite a few options which just came up from nowhere. And I could see there's this guy who's looking very close to Joe, or the person I'm seeing right in front of me. His name is Joe Casquero. Gives me a great amount of hold onto this sort of incidents and the tickets I'm going to assign to somebody or issue. Right. This particular feature where you hear the name in certain ways, but the text or the outcome of the name is very different, is called phonetic search. This is a custom analyzer built into Azure Search. Similar sounding words. All right, so we're going to pick Joe Casquero, and I'm just going to go and click on Done. Now I'm going to issue a new ticket. All the e-ticketing information is stored in DocumentDB, which is our NoSQL store. All right, as you could see here, we have Joe Casquero already been populated. We're going to provide some information like license number, make of the vehicle, and rest of the information you probably can fill in. So speeding, it was actually speeding in a region which was more residential. And we're going to put some speed here, 70 miles. And we can put some notes in. Now, all of this information, as I mentioned, is all getting stored in DocumentDB. The reason for choosing e-ticketing information to be stored in DocDB, because all these e-tickets for different jurisdiction, different cities, different states could be completely different, right? And we don't want this to be completely schema bound. This needs to be schema free sort of an implementation. Hence, we're using DocumentDB. Great, now we submit this information. Now this goes back into your DocDB and we're pretty much good to go. All right, now let's quickly look into what's really gone on the back end, and then we'll come back and look into the scenario from a supervising police officer's point of view. So let me just go and close this for now. I'm just going to stop. The debugging should stop on its own. Great. So let's look into the incident controllers. Here, if you could see, what I've done is I've put a breakpoint. And what we're doing here is we're using Elastic tool capabilities and shard map managers, which is sharing the data in real time. So there are shards for police, for ambulance, and for the fire. And the data is shared through the shard map manager. So what we're going to do here is we're going to actually go and run the API or invoke the API against the breakpoint and invoke it. So let's go and do that. Before that, because this is a web endpoint, I need to go and make my web API demo as a setup of the startup project. Once we do that, I'm just going to go and start debugging. That should open up a window and ensure that my breakpoint has been hit. Perfect. So it's all been invoked. Pretty much good to go. Let's go into our PowerShell. Now what I'm doing here is I'm importing some of the shard map management modules. So let's go do that just to ensure that it's all in here. Great. And then I just want to see which shards are available to me online. So if you see, I'm going to my SQL DB right here. That's the SQL server.database.windows.net. That's the name of my shard, password, logon credentials, and I'm just going to go and bring on all those mappings for the shards. Brilliant. Now, if you could see here, let me just show you the rest of the things. I could see that I have 3 shards, correct? One for ambulance, one for fire, and the other one for the police. Right? So we're good. So all the 3 shards are responding. We are in a good shape, and now we're going to go and invoke this REST API endpoint. Back in the slide, you saw the API we have defined here is for the cities. So there are incidents which are occurring, and then there are city IDs. The city ID I'm currently at is city ID 35, which is Seattle. So let's go and invoke this REST endpoint right now. That should go and hit the breakpoint, which is awesome. Now, if you see that it's already got my city ID right there, and that information is now need to travel and traverse through the rest of the array so that we can bring in and execute the multi-shard queries across different shards. All right, so let's go and do a step over. That shows me what my connection strings are. And then further down, it goes through my shards, and then I can go further down from here and get into my incidents query with the city ID, right? Post that, I'll go into my execute multi-shard query. Now here, I could just actually go and run the application, and this should bring all the data from those shards back into the portal. And that's exactly what you saw when you were looking at all those different responders in one frame. So let's go and hit F5. And you could see now all the data is back here for city ID 35. That's exactly what happened when you saw the application and all the incidents which was listed, right? Beautiful. Okay, now that's one piece. The second thing we want to talk about here is when we step over from that particular execute multi-shard query and go to its definition, you should see this is exactly what's happening on the back end with the query, which we're running against all the shards right here. So that's the incident model, and these are the specific parameters or columns we're running against that particular shard to bring that data back into the application page. Beautiful. Okay. Now, there are other things into this whole application, as you saw, dynamic data masking and row level security, and you can actually get access to all of that when you go through the whole source code. The next thing we want to talk about is DocumentDB. So let's go back, and also this gives me an opportunity to show you the complete deployment. As you can see here, we have DocumentDB, Azure Search, the SQL Server, or the logical SQL instance in the cloud, Azure SQL Server. And then you have all the databases, Azure SQL databases right here. Ambulance, Fire, Master, Police, and Pool, right? And before jumping into DocumentDB, I want to show you another aspect why we may want to use Elastic Pools in this scenario. As this is a software as a service application, there's a high chance that this application will start growing across different cities and states in the United States or across the world. Now, to kind of manage such resources and amount of capacity and the sort of performance we need from the application, we need to have a mechanism which can automatically allocate resources when there is a need. For that, we can use Elastic Pools. So let's go and look at Elastic Pools. What we have done here is we have added actually all the 5 databases to it. So in case of a need, let's say there's a tremendous amount of demand for or query executions against the Police database. And the Police database is getting hammered in the particular tier we are using for Elastic Pools. It will be able to consume resources from the ambulance or the fire at the same time if they are not heavily utilized, right? So that's how the resource pool thing works with Elastic Pools. Now, if you closely look at this, currently my utilization is not more than like 10 EDTUs. So I'm pretty much good with what I have selected for my EDTU setting here. But the interesting part is you can actually move this bar and you can change the Elastic Pool size. For basic tier, you have certain limitations in terms of the number of databases you can have in this, but you have the standard Elastic Pool and also premium Elastic Pools, right? This is just to ensure that you are aware of this. Okay. The next thing, as I mentioned, we're going to look into DocumentDB, where all the e-ticketing information is stored. So let's go and look at that. Okay, so we are into the DocDB, as you can see right here. I'm just going to go towards the right-hand side. And as you can see, I have all the tickets, which is my ID, the database's first response, and I've picked up a throughput and a pricing tier for DocDB. Great. Let me just show you what the Query Explorer looks like, right? So this is all our NoSQL JSON store. And as I said, we just have one collection and one database. You can have multiple collections and you can actually run your queries against it. So let's just quickly run this and see what do we really get out of this complete query execution. As you can see, all those tickets we assigned through the application, they're all getting stored here, with different IDs, depending on what sort of a violation that was, speeding and type, and then the date, right? So if you see, there's so many information right there for this particular guy, correct? And as you could see, the last one we just issued is from Jay Clarkson, speeding ticket and city ID 35. So, when we executed the application, it's all connected, right? So we added that ticket and it's showing up right there in DocumentDB. And then the search catalog, which we highlighted, was built on top of the DocDB. So eventually it's helping you with finding those names from the e-ticketing database. Okay. There's also a lot more features like GeoJSON capabilities or geospatial capabilities within DocumentDB. There's also distributed database, global distributed database, which makes things so easier so that your accessibility of a specific information and data set is more local and closer to the user and customer. And there are numerous other benefits in terms of the low latency which DocumentDB provides to you. Okay, now the last part here was that Joe thing, right? Let's go and figure out how did that all happen. So let me just go back to the code and let me just pull in the person controllers. In the person controllers, this is what my Azure Search source code is like, right? So what we're doing here is we're doing two kind of very important things. One, I mentioned that we are using the capabilities of the custom analyzer called phonetic search. Then we're also using something called a scoring parameter, and I'll let you know what exactly happens when you use that. And third, we use some of the filtering capabilities like facets, which help me pick up the male and female in the complete loop or search when I look for Joe. Okay, so before I hit this breakpoint, let me just show you what person index.json looks like. As you could see here, we have the scoring profiles information. And what we're doing in the scoring profile is we are boosting the scoring profile by some percentage. For this particular scenario, by 35+%. What we're comparing against is the location or the reference point of the officer and the field name, which is the home location. So wherever the officer is from there, if he searches for some specific criminal record or for the e-ticket information using the search capabilities, it's bringing in all the information of such offenders from the nearby region by boosting the performance and the scoring profiles. Okay, now that we have this here, I'll show you how that really is going to work. But before that, let me also show you the custom analyzer we talked about, right? So as the name thing which we added, we're using an OData type of Microsoft Azure Search Custom Analyzer with a tokenizer of standard and the name being phonetic. So when you added the Joe and Joao came back, that was all from this particular search capability called phonetic search. Sweet. So let's go back to person controllers, and I have, as you can see, I've got the breakpoint up here. Just want to make sure that we are running this perfect. So currently everything looks all right. So I'm going to go back and I'm going to go and execute and invoke my REST endpoint against this particular breakpoint. So we have the REST endpoint here, and I'm looking for Joe, right, as we rightly checked in our scenario. So I'm just going to go and run this guy. And that should go and hit my breakpoints, which is good. Now, as you could see here, it's the caller's geolocation and all the information, and then longitude, latitude, and rest of the information is all kind of captured. And then if I just hit F5 on this, what it should do is it should kind of bring back all the results. So let's go and run the results set. And now you could see that somebody with the name of Joe Healy, which we saw in the outcome, is just right there. And the scoring profile got boosted by 50% because we are looking for Joe, right? But then, unfortunately, we were looking for Joe Casquero, but then that's the mechanism we are using in terms of boosting that particular name search by using scoring profiles in Azure Search. Okay, the last thing we talked about, the facets. If you run that, it'll just give you the details of, that we are looking for male and female, and there were 8 counts of female with the same name and 11 counts, or at least there was some Joe in their name, and 11 counts for the male. Brilliant. Now, that brings me back to the previous mention that now we have a supervising police officer. How does Evan Dodds, who's one of the supervising police officers, sees this whole scenario from a perspective of analytics, visualization, and whatnot? So we tapped into 2 important aspects of the demo: easy to build experience with SQLDB, Elastic Pools, and the security features. And then we evolved and grew this application using DocumentDB and Azure Search, and we saw some of the capabilities here. Okay, let's go back to the app. So let's go and stop the debugging. And I'm going to go back and set my execution of the application back to my UWP. And I'm kind of pretty good. So I'm just going to go and start debugging. Okay. So that should open up the application once more. And this time we're going to log in with the credentials of eDots. As mentioned, eDots is one of the supervising police officer. You will see a few things differently here. First thing, that I do get to see something called as a heat map. And as you could see, there's some pretty interesting outcome, right? How are we getting this heat map? We have built an Azure machine learning model in the backend. And I'm going to show you that machine learning model, how it looks like. So let's go back to it. So that's the experiment, which you're seeing on your screen. As you can see, we're picking the 911 data set, then modeling it, picking up some of the selected column set, applying the transformation, and then normalizing it. Post which we are also kind of creating a web endpoint, and then the rest of the data is back here shown in terms of a score model. Let's just right click on score data set and just visualize it. You would see that it's going to pick up all the information about the zone, the distance, and all of that. So this is exactly how the machine learning model is showing up the heat maps on the front of the panel in the application. Okay, this is a pretty neat feature. Okay, now once this piece is done, the next thing even Dodds really wants to go and check is, I have a fair idea where exactly and which regions and what region codes we have problems or more crime going on, but I really want to have more detailed data set so that I can take actions when I have to. All right, now that we have Power BI, we are using Power BI embedded specifically for this developer experience. So let's click on this guy. What this should do is this should open up the Power BI embedded. Now this is consuming all the data from the incidents, which is basically Azure SQL database, and then e-ticketing information from DocumentDB, right? The first thing which you're seeing here certainly is going to show you a nice S3 map, which is pretty interesting in terms of the property crime, person crime, and not a criminal crime. It just kind of tells me the sort of distribution of the data and also the location. Plus, I can also see the incident analysis by time. What's been our average response time to some of the incidents are high critical or medium or low, and how we can improve that experience for the people in trouble. There's some high priority incidents, and we can actually go through the dashboard to see where the incidents really occurred. And I have a good average response time in order to kind of save people's life or reach out to the scene. But this is a 12 hours data set, which even Dodge is analyzing. The next thing is incidents by officer. So you would see here, there's a lot of different officers, Jim Jackson, K-makers, how and what sort of things they're dealing with. If you see incident analysis by priority, things have been normal, low, and their average response time have been pretty good. There's a word cloud which shows me that most of the incidents are because of intoxication, right? So there's certain actions I could take as a supervising police officers to ensure that we can reduce the number of incidents which are occurring because of intoxication, right? And then I could see how many incidents are assigned, how many of them are open, and this kind of gives me a great view of the data set which I'm analyzing and pulling back from the SQLDB, DocDB, etc. The tickets, as we said, from DocDB, it shows you the tickets by violation type, tickets by status, how many we have issued, we've been paid, how many of them have been disputed, or tickets by offense type, right? And then whether it's a traffic violation or pedestrian violation, right? And then a lot of other information, as you could see on your dashboard. Also, per officer, how many tickets they have issued in their particular jurisdiction. But this is a very simple implementation of something very big which GeoSafe has implemented, right? They are solving some catastrophic failures. We just picked that as an inspiration and built the machine learning, Power BI embedded, used a different set of backend stores to create this complete demo and show the power of Azure services. All right, I hope you liked the demo. Go and git clone the following repositories for the demo if you need access to it, and work with Azure Data Services. Right on your screens, you would see a lot of repos, and I would highly encourage you to try those, git clone, and please go and add it to our source code as well. Thank you so much for watching. Have a good day.